What's up, everybody? Welcome back to another live stream from Scalar Learning. Wednesday live stream where we are tackling SAT problems from the source from Khan Academy. Best SAT practice problems out there, period. So let's do it. Let's jump into the next category, which is solving linear inequalities. Let's go over here. Solving linear inequality, where is it? Systems of linear inequalities, word problems. Here we go. Let's make sure we're in the right Zoom. Boom. All right. Some zoo monkeys are on a diet of fruit and nuts. Fruit has about 13.3 grams of sugar per cup. Okay. And 13.36 grams of protein per cup. Okay, I'll say sugar. I'm just writing this down here, 1.36 grams of protein. Nuts have about 4.04 grams of sugar, and so this is, what is this? I'm just trying to categorize this. This is fruit, this is nuts. Has 4.04 sugar per cup and 15.56 grams of protein per cup. Each monkey must get between 70 and 90 grams of sugar per day and at least 85 of protein per day. Okay. So 60, I'm assuming it's going to be a mix. So here's what I'm going to do. This is actually a calculator problem. If I need it, I'll load it up. I'm going to just go, this is not even about making an equation. I can plug and chug and do this pretty quickly. Look, 16 grams of nuts. I can tell you right off the bat, that's going to be under 70 grams of sugar. D, right? Because it's going to be 64.64, something like that. Okay, 4 cups of fruit and 8 cups of nuts. So we would have 52 sugar and 52 and 32, that's 84. And then the protein, let's see, 8. The protein, we should be good. This might actually work. Okay, let's come back. 8 cups of fruit. 8 times that is 80 plus is 104. So we're over the sugar. You see, I'm just kind of calculating this. We're over the 90 grams of sugar. C is out. I'm pretty sure B is good, but let's see this. 16 cups of fruit. I can already tell you that's crazy for the sugar. That's going to be way over. So that was just a plug and chug. Knock it out just like that. Let's go on. Next, a memory chip is being designed to hold a number of translators and heat sinks or transistors. Transistors hold memory while the heat sinks cool the chip. Must be at least one heat sink for every 2,000 transistors to prevent overheating. Also, each transistor has an area of this. Each heat sink has an area of that. And the total area of the transistors and heat sinks must be at most 2 millimeters squared. What is the approximate maximum number of transistors that the chip can hold according to this design? Okay, wow, it's a lot of stuff here. Okay, one heat sink for every 2,000 transistors. So we've got 2 times 10 to the negative 10. Let's see, we can have at most 2 milliliters. So if we have, and the other one is 3.6 times 10 to the negative 6th. So it has to be less than 2. So it's like, there's 2 inequalities. See, this doesn't even require really a formula. What's the approximate maximum number of transistors? I mean, I could solve this. So it's like, and we need 2,000 for every one. So if I have X transistors, it's like X transistors times, what is it? 2 times, I'm not sure if this is the fastest way, 2 times 10 to the negative 10 plus 3.6 times 10 to the negative 6. And this is times X over 2,000. So it's like whatever the number of transistors roughly we'd have, it's like if we have 2,000 transistors, we'd have 1 heat sink. So it's like when this number gets to 2,000, this would get to 1. Now, it's not exactly accurate because if we have less than 2,000, I assume we're still going to have 1 heat sink. So this is kind of a rough estimate. And we could solve for x like this. This looks pretty messy, though. I wonder if there's a better way to do this. I mean, we could, again, plug in chug. So if we have 2.78 times 10 squared. See, this is 278 transistors. I might use a calculator here. This is kind of tricky. Calculator. Oops. Here we go. So let's say we have 2.78. That's basically 278. 278 times, oh my god, these numbers are so, I think that's just way too small. I think we can go way bigger than that. Okay, so I think this one is just way too tiny. This one is, here we go. So let's do it something like this. Let's say we have, I'm just feeling like it's got to be either this or this one. I'm saying 1 times 10 to the 10th. So because then we kind of nullify it and we get to 2 if I multiply it by this guy, right? You see what I'm saying? Because our max is 2. So if I go like 2 times 10 to the negative 10 equals whatever times 1 times 10 to the 10. You see, we get our area of 2. The only problem is this is not the maximum because when we get to 2 and then we also have to add on these guys, we'd like get just above, we'd have 2 of those little heat sinks. But those heat sinks are really small. So it says approximate. I think this is about the approximate. This would be a little under, but it would be, it's not the maximum. You know, this is approximately the maximum. Let's just give it a shot. Oh, they did say C. See, this would be under. This would go too far with the heat sink, but at the same time, you know, we're thinking about approximately, I don't know. So if I just did the math, I multiplied it, and I actually got that. The right amount. I feel like 2. It would be a touch over. So I don't know. Yeah, this is that equation that I was kind of writing up before, but so they actually solved it. T is less than or equal to t to the 9th. Oh, maybe I may have miscalculated. I'm gonna have to come back. I'm really running late for my next tutoring appointment, so I'm gonna have to come back to that, and I may have to abort this because I'm gonna be so late. Shoot, guys. You know what? Because I still have 3, and these are kind of long. And I've got to run to a tutoring appointment. I started this way too late. I thought I could crank it out in like 10 minutes. Here's what I'm going to do is I'm going to come back later tonight, and I'm going to finish this video for you guys. Hey, what's up, guys? I'm so sorry. I have to run to my next appointment. I'm going to come back and I'm going to finish this video tonight, and it will be up then, and then we'll take it from there. Okay, guys, thank you so much for tuning in. I'll be back to complete this video, and we'll